Hello, this is Satyam Kumar from IT Roorkee, and today I'll be taking your lectures on one of the important topics of properties of triangles, that is circumcenter. So first of all, let me tell you what do we mean by circumcenter. So it's basically the center of the circle which passes through all the three vertices of a triangle. For example, in this figure, you could see this circle passes through all the three vertices of triangle ABC. Hence, this circle, we will call it as circumscribed circle of this triangle. Now, all three vertices of the triangle A, B and C lie on the circle. So, they will be equidistant from the center O. That is, OA equals OB equals OC. If we denote the radius as R, then OA equals OB equals R equals OC, and this R we call the circumradius, since it is the radius of the circumcircle or circumscribed circle. So all the three vertices of a triangle are equidistant from the circumcenter. Now let's see what happens if we drop a perpendicular from the center O to the side BC, and let's name the foot of the perpendicular as D. Now in triangle OBD and triangle OCD, OB equals OC equals the circumradius R, OD equals OD, it's the common side, and angle ODB equals angle ODC equals 90 degree. So I'll have to erase it. So we just saw that triangle OBD was congruent to triangle OCD by RHS congruency. Since OB was equal to OC, the hypotenuse, the OD was equal to OD, of course, the common side, and this ODB angle was equal to angle ODC equals 90 degree. So these two triangles are congruent by RHS congruency, which implies BD equals CD. That is, this perpendicular OD is actually the perpendicular bisector of BC, since it is bisecting BC, because we are getting BD equals CD. So for similarly, if we drop a perpendicular from the center O to side AC and name it as E, the foot of perpendicular, and similar with side AB and name it as F, then these this OE and this OF, these two will also be the perpendicular bisector of sides AC and AB. So what we are getting, that the circumcenter is actually the point of concurrency of all the three perpendicular bisectors of a triangle. So all the three perpendicular bisectors of a triangle meet at a single point, and that is what we call as circumcenter. So we can define circumcenter in another way, that is, circumcenter point of concurrency of all the perpendicular bisectors of a triangle. Let's talk about the position of circumcenter in different types of triangles. So, for an acute angle triangle, the circumcenter always lies inside the triangle. Now, let's see. This is an acute angle triangle ABC. So, it's quite certain it's quite certain from the figure that the three perpendicular bisectors will meet somewhere inside this inside this triangle, and hence that is what we call as the circumcenter, and it will lie inside the triangle in case of an acute angle triangle. For an obtuse angle triangle, it will lie outside the triangle. I will give a detailed proof for the same later. And in a right angle triangle, it lies on the midpoint of the hypotenuse. So both this proof I will cover later. Before we move on to prove that the position of circumcenter lies outside the triangle in case of an obtuse angle triangle, we need to learn this theorem that the angle subtended by a chord at the center of a circle is twice the angle subtended by it at any other point on the circle. For example, I will give you a detailed proof. In this figure, you will see the chord BC is subtending angle BOC at the center and is subtending angle AC at some point on the circle A. Now, these two are radius. So in triangle OAB, if this is x, then this angle is also x. Since these two are same, so angles opposite to equal sides will be equal. Similarly, in triangle OAC, OA equals OC. So if this angle is y, so this will also be equal to y. Now moving on, we can see angle BOD is actually the external angle in case of triangle OAB. So angle BOB equals angle OBA plus angle AOB. Which is actually 2x. Similarly, angle COD will be equal to angle OCA plus angle AOC, which is equal to 12. So angle BOC becomes angle BOC is actually the sum of these two angles. Now x is angle BAO and y is angle CAO. So, what we are getting that angle BOC is equal to 2 times angle BAC, 2 times angle BAC. So this angle subtended by this chord at the center is twice the angle subtended by it at any other point of the circle. In this case, it is angle BAC. So angle BOC equals to angle BAC. Let's talk about the position of circumcenter in case of an obtuse angle triangle. We have a obtuse angle triangle ABC and the corresponding circumcircle. Let's assume that the circumcenter lies inside this triangle, and let's name it as O. So this angle A is obtuse, that is, it is greater than 90 degree. This angle A is actually the angle subtended by this chord BC at the center, at point A. So the angle subtended by this chord at the center must be equal to 2a, that is angle BOC must be equal to 2 angle, that is, it must be greater than 180 degree, which clearly isn't possible when the center lies inside the triangle. So this center must shift outside this triangle, let's say here. So that this angle becomes 2a. Let's take the case of an right angle triangle and see where the circumcenter lies. So this is a right angle triangle ABC with angle A being 90 degree. This angle A is the angle subtended by the chord BC at point A. So the angle subtended by this chord BC at the center O must be equal to 2 into angle A. Angle A equals 90 degree. So angle BOC must be 2 angle A, that is 180 degree, which is possible only when this O or when this center lies itself on angle, when this center lies itself on side BC, that is O will shift on BC, so that this angle becomes 180 degree, and hence angle BOC equals 180 degree will be satisfied. This is the center, so this is diameter, and hence O is the midpoint of BC. OB equals OC equals radius, implies O is the midpoint of BC. So the circumcenter in case of a right angle triangle will lie exactly on the midpoint of the hypotenuse. So the midpoint of the hypotenuse is actually the circumcenter in case of a right angle triangle.